In this video, we develop a procedure to test the validity of a statement about a population parameter. We use the population mean as the example in our following hypothesis testing procedure. In definition, hypothesis is a statement about a population parameter subject to verification. Here are some examples of statements we might want to test. For example, the man's salary is higher than a woman's salary. The mean of female student GPAs is higher than the average of the male students. The mean speed of automobiles passing a certain highway point is 68 miles per hour. The mean cost to remodel a kitchen in San Francisco is about $60,000, and so on. Hypothesis testing is a procedure in statistics whereby an analysis tests a statement regarding a population parameter. There are 6 steps in the hypothesis testing procedure. In the first step, we state our research hypothesis as a null hypothesis, denoted by H sub 0, an alternate hypothesis denoted by H sub 1. The second step is to determine the level of the significance for the testing. The third step is to identify the test statistic, such as the z-value or t-value that we have discussed previously. In the fourth step, based on what we have in the previous 3 steps, we formulate the decision rule. In step 5, we collect data in a way designed to test the hypothesis and decide whether to reject or fail to reject the null hypothesis. Finally, we interpret and present the finding in the result and discussion section. Note that the procedure could be slightly different in other textbooks or references, but the key components are the same. We will discuss each of the steps in details as follows. Step 1 is to state null and alternate hypothesis. The null hypothesis is a statement that is not rejected unless our sample data provide convincing evidence that it is false. Failing to reject the null hypothesis does not prove that null hypothesis H sub 0 is true. It means we have failed to disprove the null hypothesis H sub 0. The alternate hypothesis H sub 1 is what you will conclude if you reject the null hypothesis. We turn to the alternate hypothesis only if the data suggests the null hypothesis is untrue. There's a subtle detail here that the null hypothesis always includes the equal sign. For example, the equal, large than and equal to, or less than or equal to will be used in H sub 0. By contrast, the alternate hypothesis never includes the equal sign. For example, unequal, less than, or larger than is used in H sub 1. The second step is to determine the level of significance. There's no one level of significance that is applied to all tests. The researchers must decide on the level of significance before formulating the decision rule or collecting the sample. It is a risk you take of rejecting the null hypothesis when it is really true. The level of significance is designated with the Greek letter alpha It is also called the level of risk, or type 1 error, which can be any value between 0 and 1. The level of significance at 0.05 has been commonly used for many hypothesis tests, such as testing consumer preference in marketing research. But when we are testing for quality assurance, we typically demand a lower level of significance, such as 0.01 or even lower. For instance, in the Six Sigma theory, the level of significance can be lower than 0.001 or 0.1%. We have previously introduced the confidence level, which is equal to 1 minus significance level equal to 1 minus alpha. For example, a confidence level of 95% is equivalent to 5% significance level, or a 1% significance level is equivalent to a confidence level of 99%. Typically, we cannot be 100% confident in our data because there are two types of errors that can occur. Type 1 error, denoted by alpha, and type 2 error, denoted by beta. We choose alpha and we can calculate beta, although the computation of beta is out of scope of this course. This table is a summary of the decisions that a researcher could make and the possible consequences. If the null hypothesis is true, but we reject it, then type 1 error occurs. Type 1 error is also called false positive, such as an innocent person is convicted. If the null hypothesis is false, but we fail to reject it, then type 2 error occurs. Type 2 error is also called false negative. For fixed sample size, the lower the significance level or the type 1 error, the higher the type 2 error, and vice versa. As we have discussed, 1 minus alpha is the confidence level. If the null hypothesis is false and we reject it, the probability is equal to 1 minus beta, which is called power of statistical test. The third step is to select the test statistic. Here we use this example of hypothesis testing when the standard deviation is known. In this case, the z-value is used because the central limit theorem says that the sampling distribution of the sample means x bar is normally distributed. The mean of the sample means is equal to the population mean, mu. The dispersion of the distribution is measured by the standard error of the distribution of sample means. That is, sigma over square root of n. Using the distribution of sample means, we can calculate a z-value for any sample mean. Note that the numerator of the z-value is sampling error. So the z-value is the numbers of standard errors that separate the sample mean, x bar, and the population mean, mu. Step 4 is to determine the decision rule. In definition, the decision rule is a statement of specific conditions under which the null hypothesis is rejected and the conditions under which it is not rejected. The reason or area of rejection defines the location of all the values they are either so large or so small that their probability of occurrence under a true Lang hypothesis is remote. The rejection region is defined by the critical values, which is the dividing point between the region where the Lang hypothesis is rejected and the region where it is not rejected. We further explain the critical values in the next slides. One way to determine the location of the rejection region is to look at the direction the inequality sign in the alternative hypothesis is pointing. In the case of not equal to, the mean could be either greater than or less than. So it is a two-tail test. In a two-tail test, divided equally into the two tails of the sampling distribution, here we have 0.05 divided by 2 equal to 0.025 in each tail. Therefore, the critical values are given by the z-values, which are negative 1.96 on the left side and 1.96 on the right side, as we can look up the z-table. The negative 1.96 and 1.96 are the critical values. A test is one-tailed when the alternative hypothesis states a direction either less than left tail or larger than right tailed. For example, if reason of rejection is on the left, the critical value is equal to the z-value with 5% level of significance, equal to negative 1.645, which is the critical value for this hypothesis test. In step 5, we compute the test statistic and then compare the value of the test statistic to the critical values. If the test statistic is in the region of rejection, then we can reject the Lang hypothesis. In step 6, to interpret the result, if the result of the test result in a decision are not to reject the Lang hypothesis, we can say that based on the sample data, the difference between the sample means and the hypothesized population mean was not large enough to reject the Lang hypothesis. On the other hand, if the result of the test result in a decision are to reject the Lang hypothesis, then we have disproved the Lang hypothesis with a stated probability of type 1 error. So there's a small probability that the decision to reject the Lang hypothesis was an error due to random sampling. In this video, we introduce the 6 steps of hypothesis testing. In particular, we first state hypothesis and select the significance level alpha, and then we select the test statistics and formulate the decision rule based on the above steps. Finally, we collect data and make a decision accordingly and interpret the testing result.